Alright, what's up guys? So, I actually just recorded a whole video about this, but look, you can't see my cursor right now. Now you can. I didn't click on the screen, so I have to re-record this. Basically, I wanted to talk about a concept in programming that I learned recently. Sort of, kind of learned it in here. Cracking the Coding Interview is the book's title, and basically it just has a whole bunch of problems and shit that you may find on coding interviews, and I have one coming up, so I was practicing, and I came across this problem, and remembered a concept from a few months ago when I was reading this before that was talked about, kind of. But the problem here, a child is running up a staircase with n steps and can hop either one step at a time, 2 steps at a time, or 3 steps at a time. Implement a method to count how many possible ways the child can run up the stairs. And I'm assuming there's a positive number of stairs here. I don't really care about any of that right now. This is just for a nice, quick, simple solution here. And I solved this in 8 lines of code. So feeling pretty good about that. Very elegant solution. Basically, what happens is I figure out how many different possible ways it takes to go 1 step, 2 steps, and 3 steps, and then I use those answers to solve everything else past 3, basically. So 1 takes 1 step. The only possible thing that you can do is go 1. 2, you can go 1 1 or 2. 3, you can go 1 1 1, 1 2, 2 1, and 3. So that's 4 different possibilities, right? And then after that, what I do, for instance, for 4 here, 4 minus 3 is 1, so we use 1 plus 4 minus 2, which is 2, plus 4 minus 1, which is 3, so 4 plus 2 plus 1 equals 7. I run the code, the number 7 comes out. It's great. And yeah, it's a great program. Counts 10 steps here. Does 20 as well. Pretty big number, 121,415. Jumping ahead here a little bit. Okay, 2,555,757. It's gonna be really hard for me to, yeah, can't hide the point of this video for too much longer here, because something's up with my program. It's taking a little while. I only bumped it up by 5. Oh, yeah, there we go. This is 53 million different possibilities. Let's bump it up by 5 again, see what happens. And this brings me to my topic for the video. Short code is not necessarily good code. These 8 lines, sure, it works, but it's slow as shit, and I'll show you. Look, a different answer. Wow. This one, what it does, as you can read here, stores the values for better running time. So basically the whole way this works is I start at 4, and then I open up 3, 2, and 1, and then I solve for those. So what ends up happening is you do a lot of repeated work that's not really necessary. You end up running the same math more than once. So let's say there's 6 steps. We get 3, 4, and 5. And now if we want to calculate 5 steps, we get 2, 4, or 3, 4, and 5. This is 2, 3, and 4. Sorry. 2, 3, and 4. So 3 and 4 from the 6 are opened up twice, so there's the extra work right there. Hopefully I explained that right. So for 6, 3, 4, and 5. For 5, it's 2, 3, and 4. So the 3 and 4 from 6 are now 3 and 4 for 5. Probably lost some people there, but basically you're opening up 2 extra recursive branches here, which really slows your program down. I think the running time for this is 3 to the n, which is really bad. Whereas for this, I think it's n log n. I don't exactly know what the running time is, but it's way better. And basically what this does is, instead of starting from the top and opening up all the branches and then getting to the bottom and then solving everything and eventually closing, you start from the bottom, I store the values here. Then what I do is I call my recursive function, which is here. And then what I do is I use the data that's previously been stored to solve for this stair number. That's pretty much it. And then what I do once I solve that, I store that value into my little array thing here. And if I'm at the target number of stairs, I return, or if I'm not at the target number of stairs, I recurse again 1 time. And if I am, I just return the sum that I calculated earlier. That's it. And yeah, this takes, it's about 21 lines with some space in between. Let's say like 18 lines here, 15, 18 lines. So it's slightly longer, looks kind of shitty, but yeah, this is still running. So we're gonna stop that, uncomment this out, and let me show you the power of just reducing these branches. So 35, done. 50, done. 100, done. 200, that was fast. 300, 600. I can't even count that high. So you see the power of storing these previous values. It really, really, really helps. I wonder how far you can go, because I know this errors out eventually if you recurse too far. 800, 900. Wow, I know you can't do 1,000. 950. Okay, I've proven my point here. I'll show you what happens when you do 1,000. A red text, which is always bad. So yeah, I think I proved my point here. This elegant, short, simple code isn't necessarily something to be proud of, I guess. Just test your stuff. Brute, put stress test your code, and yeah. This concept, very, very cool, very interesting to me. So I figured I'd share. And yeah, have a good one.